Okay, we have a solid stainless steel shaft that is 72 inches long. It will be subjected to pure torque. Determine the minimum diameter required if the shear stress must not exceed 8,000 psi and the angle of twist must not exceed 5 degrees. Report both the maximum shear stress and the angle of twist at this minimum diameter. Okay, so we have a solid shaft and we are trying to determine that diameter. And I know that if I'm looking for maximum shear stress, it's going to come from using my radial link. So our maximum shear stress is TC over J. And I also know that the diameter I'm looking for is 2 times that radius. Okay. So if I can find a diameter based on shear stress, a radius based on shear stress, then I can back calculate. So if we're looking at the shear stress, our torque is given at 900 pound-inches. And I'm going to convert everything to KSI just from the get-go. So I have 9.9. So 1, 2, 3.9 kip inches. And I have a allowable shear stress of 8,000 PSI. And so that's going to be 1, 2, 3, 8 KSI. And I don't know the diameter, so I don't know that radius. If I'm looking at angle of twist, I have G, that's going to go on the bottom, is 12,500 KSI, so we're already in our appropriate units. And we have a length of 72 inches. We also have a torque of 900 pound-inches, but we've already converted that over here to kip inches. And our angle of twist is at 5 degrees, but we need it in radians. How do we get it in radians? Well, we're going to go back to our perfect little circle that we like to draw, and we have 1 revolution, we have 2 pi, we have 360 degrees. So how do I go from degrees to radians? It's going to be a ratio of these two. So I have 2 pi over 360, and that'll get rid of the degrees and put me back into radians. So let's start by, let's assume that we have failure, or we need that minimum diameter caused by the shear stress. So shear stress is TC over J, and I can come over here and I've got 8 KSI equals 0.9 kip inches times C divided by pi over 2 C to the 4th. I can get rid of this C and make that cubed. So I now have 0.9 over pi over 2 C cubed. So let's just rewrite C cubed equals 0.9 over pi over 2 divided by 8. And our units should all be working out because we've put them in unit form up here at the top. So I have 0.9 pi as a number. Oops, that is wrong. Pi as a number. 2 divided by 8 times and divided by, and I get 0.0716197 inches cubed, which means that my radius is cubed root 0.415, 0.41528 inches, which means my diameter that I need, 2 times 0.831, 0.831 inches. So this is the minimum required diameter. So this is my minimum required diameter to prevent failure from shear stress. Now we're going to look at, well, what prevents the failure from our angle of twist. So phi equals TL over JG, and we're going to start filling it in. So I have 5 degrees times 2 pi over 360 equals T, 0.9 kip inches times length, 72 inches, divided by J, pi over 2 C to the 4th, G, 12,500 KSI. So I'm in kip, inches, KSI, those come out, perfect. So I'm going to rewrite this so that I have C to the 4th equals 0.9 times 72, okay, and then we have a lot of stuff on the bottom. Pi over 2, 12,500, and then we're going to have 5 degrees times 2 pi over 360 degrees, And so if we work this out, then I'm going to get 0.972 times pi as a number, 2 divided by 12,500 times 5 times 2 times pi as a number times 360 divided by, and then we can divide that out, and I get 0.03718 inches to the fourth. So now I need to take the fourth root of that, fourth root, and I get that C equals 0.44099 inches. So the minimum diameter is, voila, 0.882 inches. So this is the minimum diameter I need to prevent failure from my limit of 5 degrees. So which one do I pick? Well, the minimum I need here is 0.88. The minimum I need here is 0.83. So 0.88 will work perfect for 0.83, and it has to be at least this big to prevent failure here. So the diameter I'm going to use is 0.882 inches. And I want to take a little sidetrack here. You know, a lot of times you have to figure out to the nearest eighth of an inch. And so I just kind of start setting up, well, that's bigger than 0.75, which is 6/8, and 7/8, and then I have 8/8 because I don't know where it's going to fall. So 7 enter 8 divided by is 0.875. And so when I look at this, I see that it's falling right in here. Okay, it's between 7/8 and 1 inch diameter. Well, do I round down to smaller or do I round up? If the minimum is 0.882 inches, I cannot go down. So if I were having to round this to the nearest eighth of an inch, I would go with a 1 inch diameter bar. Okay, so now the rest of the question stated, it stated what is the shear stress and angle of twist at this. So we go back and we can now do shear stress. I know it's TC over J. My torque is 0.9 kip inches. My radius is that 0.882 over 2, because remember that's my diameter. And then J is pi over 2, 0.882 over 2 to the fourth. And we are going to get 0.9, 0.882 enter, 2 divided by pi, whoops, drop, go multiply, pi as a number, 2 divided by 0.882 enter, 2 divided by to the fourth, times divided by. And I get 6.68, okay, and remember that was in kips, so KSI, which equals times 1,000, 6680 PSI, which is, I expected it to be less than 8,000 PSI because 8,000 was what we had for our limit, and we made a bigger diameter, so it's going to make our shear stress smaller. And then at this point, we know that we have 5 degrees for our rotation because that's what set our limit. So there is the solution using both criteria to determine a radius.